Here we are going to break down the U-Try for Lesson 6, solving absolute value equations from our equations topic. So if there's any problem that you got a little bit stuck on, or you're not sure how to get started, or your work doesn't match the answer that I had, please feel free to watch this video for an explanation of any or all of these problems. Important thing to remember is that for absolute values, we have to set up two separate equations because the absolute value is the distance from 0, and that distance can travel to the right in the positive direction or to the left, the negative direction. However, before we set up those two problems, we want to make sure our absolute value, or our house, whatever you might call it, is completely isolated on that left-hand side. So if I just drew a little line and I look at that left-hand side, is the only thing I see the absolute value and what's inside of it. And if the answer is yes, which it is in this case, we're ready to set up our two equations. So our first equation we set up just as is. We just drop our bars. And now to differentiate, I'm going to use a squiggle so we know this is a separate equation, and I'll use a different color. Now we're going to take what's inside and we're going to keep the inside exactly as it is, and instead of setting it equal to positive 10, we're going to set it equal to negative 10. And so now we have two equations to solve for. Okay, so now I'm going to draw my line down each of them, and I'm going to put in my box the x. And so now for that first one, to get the 7 over, I'm going to subtract 7. Bring down my box. I get x equals 10 minus 7 is 3. Done. X is by itself. We cannot assume that the other answer is also just going to then be negative 3. That's not how it works. So we need to actually subtract that 7, and we find x is equal to negative 17. So we have two answers for our absolute value, and if you want to write it as like a little solution set, we can say I put the smallest number first, negative 17 and 3. All right, let's look at number 2. If I draw my little division line at that equal sign, my question is that absolute value the only thing in my house? And the answer, or only thing on the left? And the answer is yes. So I'm ready to set up my two equations. So I'm going to set up 5x plus 15. I just dropped the bars, equals 20. And then my second equation, I'm going to take 5x plus 15, and instead of setting it equal to 20, we're going to set it equal to negative 20. I'm going to draw like a little squiggle so you know that these are two separate equations, and I'm going to move a little bit faster through this solving process because we've been doing it now, for a while. So I'm going to get the 5x by itself, and I'm going to do that by subtracting the 15. Bring down my arrow, or my 5x with an arrow. 20 minus 15 is 5, and then I'm going to get my x by itself by dividing both sides by 5. I get x equals 1. Okay? On the equation, or for the equation on the right, we're going to do the same steps, but they're not going to leave us with the same values or even the opposite values like you might think. So I'm going to bring down my 5x. I'm going to subtract 15 because I'm moving it over, so I'm doing the opposite. Negative 20 minus 15 gives us negative 35. And then I'm going to get x by itself by dividing both sides by 5. And negative 35 divided by 5 is negative 7. So our solutions for this problem is x can be negative 7 or positive 1. When I plug both of those equations in for x, I will simplify that left-hand side, and when I take the absolute value of it, it will give me 20. All right. 3 and 4, when we're looking at 3, we're looking at the left-hand side of that equation. Is the only thing I see the bars and what's inside the bars? And the answer is yes. So I'm ready to set up my two equations. The first one, I'm just going to drop the bars and keep everything else as is. My second equation, I'm going to keep the inside of the absolute value as is, but I'm going to swap that 6 out for a -6. From here, I'm ready to solve my equation. The first thing I'm going to do is get my variable x divided by 3, that term by itself. How I do that here is I'm going to add 2 on both sides. Bring down x divided by 3. 6 plus 2 is 8. And then now to get the x by itself, the opposite of dividing by 3 is to multiply by 3. And so I'm going to do that on both sides. That crosses out that 3 on the left, just leaving us with x. And 8 times 3 is 24. Same process is going to take place in our second equation. We're going to add 2 on both sides first, and we're going to bring down that x divided by 3. -6 plus 2 is -4. And now we need to get rid of that division of 3, so we're going to multiply both sides by 3, crossing that out on the left. -4 times 3 will give us -12. So our solution set here, -12 and +24. All right. Number 4, if we take a look at number 4, that left-hand side, the only thing you see on that left-hand side is that absolute value. There's nothing in the front yard, nothing in the backyard, so we're good to go and set up our two equations. So we're going to take 3x minus 4, set it equal to -12. Ooh! And I look and I think, oh my goodness, why didn't I notice this earlier? I wasn't even looking at that side. Can an absolute value ever equal a negative? And hopefully you're yelling to me right now, no, that is not possible. I cannot take the absolute value of some number and it spit back a negative number. So when you see this, do not get caught up and start solving. Once you see that it's a negative, you know there's no work for you. It's going to be no solution. So I was looking at if it's isolated, and I almost missed the fact that the right-hand side was -12. So I did catch it when I went to set up my two equations, but it would be wrong if I continued to solve those equations. And then if I set up a second one equal to +12. We cannot have an absolute value equal a negative. So once that house is by itself, if that house or that absolute value equals a negative, that's a major, major no-no, and we have no solution. That's the empty set. The last two, we gave you something where the house or the absolute value was not isolated. So here, if I draw my line, a little line, and I say, okay, is that thing highlighted in yellow, that absolute value? Is it by itself on the left-hand side? Hopefully you all agree and are answering no. There's that -3 in the backyard. So before we set up our two equations, we have to get rid of that -3. Okay? Whoopsie. So how we're going to do that is we are going to add 3, just like we've been doing. But we're not ready to set up two equations. And in fact, if you set up your two equations before, you're not going to get the right two answers. Now is that absolute value by itself on the left-hand side, and now the answer, you hopefully all agree that the answer is yes. So I'm ready to set up one equation. all I do is drop the bars. And then for my second equation, I will drop the bars on the left, and I change that 19 to negative 19. Now we're ready to try and solve, or to solve both of these. Hopefully from here you're good to go. So to get that negative 2x by itself, we're going to subtract 5 from each side. We're moving it over, so we got to do the opposite operation. 19 minus 5 is 14. And then from there, we're going to divide both sides by negative 2. That's saying negative 2 times x. So that gives us negative 7. Now we're ready to solve the next equation. So we're going to subtract 5 from both sides. Look at that. I didn't even put my negative 2x in the box. There we go. Bring that down. You are hopefully getting in the habit where you're like, I don't even need the box. Negative 19 minus 5 is negative 24. And then we're going to divide both sides by negative 2. Negative 24 divided by negative 2 will leave us with 12. And so our solution set, the two values that will satisfy this absolute value equation, are negative 7 and 12. And last but not least, number 6. So if we're looking at these absolute values and what's inside the bar, and you ask yourself, is that the only thing on the left-hand side? The answer is no. There's something in the front of those absolute values, and you need to recognize how it's attached to the absolute value. Is it being added or is it being multiplied? And here, because we see that 2 and we see that bar and no other option or no other operation in between, we know that it is being multiplied. So to get it to the other side, we're going to divide both sides by 2. Now that does not affect anything in the parentheses. That's only going to get rid of that there for us. And I'm going to squeeze the problem up here. So we have x divided by 5 minus 4, and then 10 divided by 2 is 5. Now our bars, or our absolute value, is by itself, so now we're ready to set up our two equations. So the first one's going to look exactly like we see. We're just going to get rid of those absolute value bars. And our second one, we're going to write what's inside those bars exactly as is. And instead of setting it equal to positive 5, we're going to set it equal to negative 5. All right, let's finish strong. To get rid of minus 4, we're going to add 4. Bring down what's in our box. 5 plus 4 is 9. And then last but not least, we need to get rid of that division of 5. So the opposite of dividing by 5 is to multiply. And so we're going to multiply both sides. So we're left with x equals 45. All right, here we go. Draw, whoopsie, different color. Draw our line down, put our x divided by 5 in our box. We're going to move over that minus 4 by adding 4. Negative 5 plus 4 gives us a negative 1. And then to get rid of dividing by 5, we're going to multiply by 5. Remember, that's going to cross out both of those 5s, just leaving us with x. And negative 1 times 5 is simply negative 5. So our solution for this problem, or our solution set, is negative 5, 45. So hopefully you found that helpful for absolute value equations. We are going to round out our equations unit. And if you have any other questions, comments, or concerns, hopefully we will get those answered. Keep up the great work.